Good morning, good afternoon, and good evening, everyone. I wish to thank the organizers and the sponsors for once again inviting me back to give a presentation in this awesome global virtual event for the sixth year since 2020. The topic I'm presenting today with my co-presenter, Vincent, from Infront Consulting Asia, is titled Security Copilot and SCOM, a new and better together approach. Here is a little bit about me. My name is Wei Hao Lim. You can call me Wei. I'm a Microsoft Principal Cybersecurity Cloud Solution Architect based in Melbourne, Australia. I specialize in multi-cloud monitoring, security and AI solutions, threat detections, data visualization, and automation design. And then I am across Microsoft Security Copilot, Sentinel, Defender for Cloud, SCOM, Azure Monitor, and Azure Cost Management. I work mainly with enterprise customers to implement and demonstrate the value of Microsoft's security and AI services, monitoring solutions, and help remove technical blockers, drive success, customer confidence, usage, and consumption of our products and services to help make our customers more secure. It is such an honor to be here today to speak to you all on this topic that I am very passionate about and a security product I am heavily involved in since it was launched around this time last year, which is Security Copilot.
Hi, my name is Vincent. I'm the principal consultant from Infront Consulting Asia. I'm specialized in multi-cloud monitoring, data visualization, and automation design, particularly through the use of the Microsoft solutions such as SCOM, Azure Infrastructure, Azure Monitor, and Azure Cost Management. I work alongside enterprise clients to implement and demonstrate the advantage of Microsoft offering, how to tackle technical obstacles, and improve customer success and trust, and also the overall operation of our product and services.
The objective of this session is to explore the benefits of extending your SCOM environment with a generative AI solution like Security Copilot, and how it can enhance the efficiency and effectiveness of monitoring or observability in complex environments while strengthening the overall security posture of your organization. Then, I will demonstrate an approach that brings SCOM and Security Copilot closer together by enabling real-time querying of SCOM data directly from within Security Copilot. Here is the agenda for today's session. The agenda is organized under the following topics. We will first do a quick overview of Security Copilot and briefly highlight the new AI-powered agent capabilities in Security Copilot. I will then go straight into a demo on how we can use Security Copilot to deliver a health and security assessment of SCOM monitored components within a distributed application in real time. Next, I will go into detail on the approach that I have developed to enable real-time querying of SCOM monitoring and security data directly from within Security Copilot and how to customize it. Security Copilot is a generative AI security solution that helps increase the efficiency and capabilities of defenders to improve security outcomes at the speed and scale of AI. With Security Copilot, security analysts can move faster, so a shorter time to response and remediation, and more time to focus on high-value tasks. It provides a natural language assistive Copilot experience that helps support security professionals in end-to-end scenarios such as incident response, threat hunting, script analysis, security reporting, and posture management. Security Copilot combines the most advanced GPT-4o model from OpenAI with Microsoft's hyperscale infrastructure, an orchestrator trained on security-specific plugins, prompt books, including organization-specific information, authoritative sources, and global threat intelligence. It's much more than just a large language model behind the scenes. I'd like to briefly talk about the new agent capabilities in Security Copilot. Microsoft recently introduced new AI-powered Security Copilot agents designed to automate and streamline critical security tasks. These agents are built to learn from admin feedback, improving their accuracy and efficiency over time. The phishing triage agent in Microsoft Defender helps triage phishing alerts, identifying real threats while providing clear explanations. In Microsoft Purview, the alert triage agents prioritize data loss and insider risk alerts, while the conditional access optimization agents in Microsoft Entra ensures security policies cover new users and apps. The vulnerability remediation agents in Intune handles app and policy vulnerabilities, while other agents provide tailored threat intelligence briefings and streamline Windows OS patching. Together, these agents enhance security operations, making them more proactive, efficient, and adaptive to emerging threats. Security Copilot is intuitive, customizable, extensible, while supporting responsible use of generative AI. It meets users where their daily workflows exist and natively integrates with existing tools through the standalone and embedded experiences in other Microsoft security products. Today, capabilities like custom plugins, prompt books, logic app connectors, and knowledge-based integration empower users and the teams they collaborate with to use Copilot together with their organization's existing processes, tools, templates, and workflows to accomplish their daily tasks. By integrating Security Copilot with your internally developed processes and monitoring frameworks in SCOM, you can improve your security insights, response efficiency, and operational workflows. The goal is to show that Security Copilot doesn't replace your current tools. It enhances and extends them, helping you get maximum value from both your investment in SCOM and your in-house expertise, as I will demonstrate in the next section. In this example, we will start our initial assessment from the Microsoft Security Copilot standalone portal. I will be using Security Copilot to provide a comprehensive health and security assessment of all monitored components of a distributed application in my organization named Contoso in a role as a security analyst. The health, security, performance, and alert information of these monitored components are generated by a custom SCOM management pack created specifically to monitor this critical application and will be retrieved from an integrated SCOM environment in real time to be used for the health and assessment report in Security Copilot. So let's go to the Security Copilot standalone experience and run the prompt book to generate the overall health and security report for the Contoso critical application. I will click the Start a New Session button in the prompt book library under my prompt books. It will start a new session with the sequence of prompts to be submitted to the orchestrator and the large language model of Security Copilot to evaluate. I will scroll to the right and click the Submit button. So when I click the Submit button, the first prompt will run. As you can see, the public web plugin is selected, and then my request is processed with the right skills. So the URL provided in the prompt is actually a HTTP trigger that invokes an Azure Logic app, which kicks off an Azure Automation PowerShell runbook in my Azure subscription. The PowerShell runbook connects to my integrated SCOM environments via the SDK service using SCOM PowerShell commandlets and retrieves the list of security alerts for the Contoso critical application over the last 24 hours. Security Copilot waits for the response from the provided HTTP trigger URL and retrieves the list of security alerts for the model to evaluate and analyze, and provide a breakdown of alerts per monitored host or server, as seen here in the result of the first prompt. We can see that 4 servers here have various high and warning levels of alerts. For the database server, OMDB0, we see that environment availability and performance state assessment monitors have high severity alerts, possibly due to these high and medium severity security alerts, like a suspicious process creation was executed. The other 3 servers also have a different mix of environment state assessment monitor alerts and security monitor alerts, with the second server, OMMS0, having less amount of security alerts. This could imply that the Contoso critical application is in the midst of a cyber attack. Now let's quickly switch to the integrated SCOM environment and take a look at the SCOM alert view in the operations console. Here we see that the alert view is flooded with alerts from the custom management pack that is monitoring the critical application generated within the last 24 hours. When the alert view is overwhelmed with a high volume of security alerts within a short time, like this, or during a cyber attack, time becomes critical, and analyzing each alert individually is no longer practical. In these high-pressure scenarios, Security Copilot can help to analyze and interpret the flood of alerts, providing a clear, contextual understanding of the situation, like what you see in the standalone portal here from the first prompt. Now, moving on to the second prompt, which just completed, is the same approach, but with a different HTTP trigger URL, connected logic app, PowerShell runbook, and script, but in the same Azure subscription. Security Copilot waits for the response, and this time the details about the Contoso critical application computer roles and the health states are retrieved for analysis by Copilot. And here is the result with the key properties for each host or server under the critical application displayed. Quick check here, we can see that the database server and the access management server for the Contoso critical application is not in a healthy state. While one app server is still in a healthy state and the other one is not. The information provided by the result of the second prompt here is so important to provide additional context to the session and how these security alerts are affecting the Contoso critical application based on their application roles. We now move on to the third prompt with again a different HTTP trigger URL, connected logic app, PowerShell runbook, and script, but in the same Azure subscription. And this time, the performance data for the host or servers under the Contoso critical application is retrieved for analysis by Copilot, including indicators of outliers. The performance data includes available memory in megabytes, CPU usage, and the threat score for each of these critical application servers. We can see that the threat scores of the app server agent OMMI and the access management server are particularly high, mostly due to the amount of high severity alerts generated by them. With the performance data for each of the controls or critical application servers included in the context of the sessions, we can utilize it to find out whether the ongoing cyber attack is impacting server capacity and their overall performance, like a DDoS attack. I can see now that the CPU usage of the database server has spiked up to almost 100% in the last 24 hours. Switching quickly to the operations console, let us check the CPU usage of the database server. And in fact, there were some erratic CPU usage levels over the last few hours detected. And for the last prompt, we use the generic capability of Security Copilot to refer to the context in this prompting session and write a report with all the contextual information, merge the health, alert, and performance data for each of the servers, then summarize the findings from the investigation, and then conclude with a set of recommendations based on the role of each of these servers in the critical application. So the response of this prompt is generated based on OpenAI GPT-4o large language model, which is good at general knowledge and problem solving. As seen here, it took less than 30 seconds to generate the overall health and security report for the critical application from the monitoring and observability data generated in SCOM. In this report, we see that the computer role, health state, alert generated, and performance state for each of the critical application servers is provided. And then it provides a summary of the findings. And finally, in the recommendations section, as instructed in the input prompt, to conclude with a set of recommendations based on each server's role in the critical application, we see specific guided recommendations provided for each critical application server by using the information available within the context of the session. For example, for the access management server, the recommendation is to address active high severity alerts focusing on suspicious processes and power supply activities. And for the app server is to address active high severity alerts, especially those related to ransomware and unauthorized executable runs, or particularly those related to registry changes and PowerShell commands as well. Okay, so this report provides a comprehensive analysis of the health, alerts, and performance data for each server, along with actionable recommendations based on their roles in the critical application. You can run an additional prompt to summarize the report further to produce a non-technical executive level summary that can be shared with other teams in other departments or a company's leadership team. Right, so for example, summarize this report further for a non-technical audience. So here it uses its generic capability and summarizing the report further. Here we go. So summary of critical application servers, and it is a lot less complicated compared to the previous report. You can also further extend this session by asking Security Copilot to elaborate on the high severity security alerts and ignore warnings, explain them in detail, provide possible risks or impacts and possible solutions for them based on each server's role in the critical application. So let's run a prompt. Ask GPT to extend on each high severity security alerts. Only ignore warnings. Explain them in detail. Provide risks or impacts and solution. Impact and solution for them. Use per each server's role in the critical application. So here we see the output. So based on each server's role in the critical application, we see the explanation, risk and impact and solution for each of the alerts that they have generated. Now, say the cyber attack was successfully mitigated for the critical application in Contoso and all security monitoring alerts are hence closed. Let's go to Security Copilot and run the prompt book again to generate the overall health and security assessment report for the Contoso critical application in real time. Here we see that the results have been updated in the report to show the most current state and details of each server under the Contoso critical application. For example, all of the alerts are closed for the servers under the critical application. And each server or each computer role under the critical application is currently in healthy state. The threat scores, the current threat scores or the average threat score is so these are the performance metrics. And yeah, so alerts have been closed. Here is the summary of the findings and recommendations based on what happened to the components under the critical application over the last 24 hours. This concludes the end-to-end demonstration of how Security Copilot can be leveraged to deliver a comprehensive health and security assessment of all SCOM monitored components within a distributed application. It not only provides actionable recommendations tailored to the roles of each component, but can also be extended to perform risk and impact analysis along with guided remediation steps. Additionally, from the demo, we see how Security Copilot can help empower security teams during active cyber attacks by helping them make sense of complex and rapidly evolving data. In high-pressure situations where multiple events unfold simultaneously and time is critical, it can help offer a clear, concise, and real-time view of the threat landscape. By correlating signals, prioritizing alerts, and suggesting remediation actions, Security Copilot enables faster, more informed decision-making and helping teams respond effectively to contain and mitigate threats. Now, let's take a look under the hood on how this solution is built. Before delving deeper into the details, here is an overview of the solution. At the core of this solution is a SCOM integration that provides environment-specific monitoring data, enabling Security Copilot to query it in real time. By using Azure Logic Apps and Azure Automation Runbooks, we can query SCOM directly through prompts and promptbooks in Security Copilot, where the power of its large language model enables contextual analysis. And as seen from the demo, Security Copilot can retain context in its sessions, consolidates information from multiple sources, and effectively presents a comprehensive end-to-end narrative. Let's take a closer look at the key components of the solution. We'll break down each one to show how it's set up, how it's configured, and highlight the key points you need to know so you can clearly understand how everything fits together to bring the complete solution to life. Let's start by looking at the SCOM environment and the access component, which form the first building block of the solution. The solution will work for both SCOM managed instance or a classic SCOM environment. For both instances, the Data Access Service or SDK of the SCOM managed instance endpoint or the management server must be accessible over the network with its FQDN using the new SCOM Management Group Connection commandlet with a set of credentials assigned to the right user role in the SCOM environment. After connection is established with your SCOM environment, you can run your PowerShell scripts with SCOM commandlets to retrieve monitoring data from it. Prepare a script with SCOM commandlets that will be used as an input and to perform testing in the next component of the solution. The next component of the solution involves creating an Azure Automation account and a PowerShell runbook. Remember to give them meaningful names that reflect their purpose. making it easier to manage, understand, and troubleshoot later. Once the automation account and runbook are created, you can add the SCOM modules under Runtime version 5.1 in the Modules page in the Shared Resources section of the automation account. And you can also add the SCOM access account in the Credentials page in the Shared Resources as well. You can then import the SCOM modules, access the credentials, add the SCOM commandlet to connect to the SCOM environment FQDN, and the script that was prepared into the PowerShell runbook when you start to edit the runbook of the automation account. You can then publish the runbook after you have completed these steps. After this, we move on to the next component of the solution, which involves creating an Azure Logic app. Again, reminder to give it a meaningful name that reflects its purpose. With the Logic app, add the automation account create job and get job output connectors first. You can link the create job connector to the automation account and target the PowerShell runbook that you created and published for the automation account in the previous component. The get job output connector outputs the results of the runbook when it is triggered from the Logic app from the create job connector. For the Logic app trigger, use a HTTP trigger to trigger the runbook linked to the create job connector. Take note and copy the unique callback HTTP URL that will be used to send the HTTP request to trigger the Logic app. Add the HTTP response action as the last connector of this Logic app. This is to model the response and send the payload results back to the caller. Note that this combination with the request trigger and response action creates the request response pattern. And finally, in Security Copilot, the unique callback HTTP URL for the HTTP request trigger in the Logic app can be included in the prompt with the public web plugin to trigger the runbook in the Logic app and wait for the payload results to be sent back as a response and then evaluated by the large language model in Security Copilot. Please ensure that the public web plugin is enabled in the Security Copilot standalone portal before running the prompt. Using the prompt, you can create a prompt book for convenience and repeatable use. So instead of retyping a complex prompt each time, you can simply click on the Run button to execute it whenever it is needed. This approach allows you to leverage even the most basic commandlets, such as get SCOM management server and get SCOM agent, which are commonly used by SCOM administrators to programmatically query the status of management servers and agents. Typically, you would refine these commands by selecting specific properties or applying filters with where clauses to tailor the output. Whenever simple or customized, these PowerShell commands can be executed in real time directly from a prompt or a prompt book within Security Copilot, enabling efficient and repeatable interaction with your SCOM environment. Let's see how we can customize this further with some simple examples, tailoring a basic SCOM commandlet to return only the most relevant information for your scenario. Let's see how we can add a new get SCOM management server command line with selected properties into an existing workflow based on this solution. To implement the change, we only need to add the new command line into the PowerShell script of the automation account PowerShell runbook of the existing workflow. Here is the PowerShell runbook that we want to modify. Click Edit in Portal. Notice the module used and the new SCOM management group commandlet with the publicly accessible DNS name of the target SCOM management server. Now we copy the new command line from here. And we place it in the script. Note here that I have selected to return only the health state, display name, version, heartbeat interval, and its gateway properties for this command line. We save it and we publish it. Now, I have also prepared a prompt book that runs a single prompt with a HTTP trigger to run the commandlet and retrieve the response from the integrated SCOM environment based on this solution. Switching to Security Copilot, go to Prompt Book Library, My Prompt Books, and this is the prompt book. Run this prompt book. Wait for the result. Here, we see that the result from the integrated SCOM environment with the new command line return only the values of the health state, display name, version, heartbeat interval, and its gateway properties of the management server. Next, let's see how we can add a new get_scom agent command line with selected properties into another existing workflow based on this solution. Like the previous example, we only need to add the new command line into the PowerShell script of the PowerShell runbook of the existing workflow. Here is the PowerShell runbook that we want to modify. Click Edit in Portal. We can copy the new command line from here. And replace it in this script. Here, I have selected to return only the health state, display name, version, heartbeat interval, primary management server properties for all agents for this command line. We save it and publish it. And that's it. Now, I've also prepared a prompt book that runs a single prompt with a HTTP trigger to run the commandlet and retrieve the response from the integrated SCOM environment. Switching to Security Copilot, we go back to the prompt library again, My Prompt Books, and this is the prompt book. Start a new session and submit. Here, we see that the results retrieved from the SCOM environments with the new command line return only the values of health state, display name, version, heartbeat interval, primary management server properties for each of the SCOM agents in this SCOM management group. With the information of these agents available in the context of this session, we can ask Copilot to use the Defender plugin to check the vulnerability state of these agents and guidance on how to remediate the identified vulnerabilities, including patching, configuration changes, or other recommended actions. Or we can use the generic capabilities of Security Copilot's LLM to ask it to refer to the context, rank these servers based on their importance in a SCOM environment, and recommend steps to ensure their availability. So here's the result. In a SCOM environment, the importance of servers can be ranked based on their roles and functions. Here's the ranking of the servers mentioned, along with recommended steps to ensure their availability. So as we see here, the importance of the operational database or database server is high, and the management server is high as well. The domain controller is medium, essential for authentication and directory services, and the importance of agents is relatively low. So interesting that it picked up the management server from the context as well and ranked it as high, right? So it is within the context as we see here, the primary management server of these agents. So in this session, we show how your SCOM environment can be further enhanced by integrating Security Copilot with your internally developed knowledge and operational workflows for monitoring and security. We also saw how we can bring SCOM and Security Copilot closer together with a solution that enables users to query real-time SCOM data through natural language prompts within Security Copilot interface. As demonstrated, Security Copilot retains context across interactions and consolidates data from multiple sources, including SCOM, to present a comprehensive end-to-end narrative. Finally, rather than replacing your existing tools, Security Copilot enhances and extends them, helping you maximize the value of your SCOM investment and internal expertise while empowering your security teams to make faster and more informed decisions. I would like to sincerely thank each and every one of you for taking the time to attend this session. Your presence, support, and encouragement truly mean a lot to me, and I'm deeply grateful for your continued engagement. Please enjoy the rest of the sessions in this awesome virtual event. Thank you.